Okay, what I want to do today, Matt, is have you walk through the Toolpath properties, all the different tabs here,
Mhm.
what they do and what they mean, because I know we have a ramp plunge in here, and then we have a ramp also in our tool set, and how do those work with each other?
Okay, so I'm gonna grab control real quick.
You 100%. Yep.
Yeah, I don't know if that comes up on your end.
Okay.
Yeah, so now I can move around. Yeah, perfect. Okay, so before we start in here, let's talk about libraries CNC tooling
Okay.
because you mentioned the ramps in here. So the tool parameters, each tool has its own unique tool parameters as well as speeds and feeds and then application. So you can set what that tool is going to be used for automatically. So cutouts, drills, dados, pockets. Some of these have their own options when it comes to like dado options or cutout options. But the ramp that you're seeing here would only apply to now it's kind of funny because you get like some of these tools will actually have a value here, but this
Yep.
value only applies when you're using it for a pocket tool. So if you had say like the 8300 and you set this as a pocket tool, it's going to follow this pocket ramp. So
Okay.
that's the horizontal distance that the tool travels when it's ramping into the pocket. So it's just not going to plunge straight down because sometimes these tools are not capable of plunging into the pocket. They have to ramp in. That's what that's for. This does not apply to any like cutout tools. It's only going to be for pocket tools.
Okay, just if that tooling is set to pocketing.
Yeah, correct.
Okay,
Yeah.
perfect,
So
perfect.
ramping, this is like traditional ramping. So it's just going to come in. It's going to basically your machine's going to wrap it down to the safe value above your material, and then it's going to use the plunge value to plunge into the material at an angle. This is the distance that that tool is going to travel when it's ramping. So it's gonna come in and it's going to do a 2-inch ramp. So the angle of it depends really on the distance that it's traveling here.
Okay.
If you turn that off, it's just going to plunge straight in. Now, depending on the machine, there's certain machines like home egg machines, you actually have to turn the distance to 0 and turn this off because the home egg machines they're gonna override that. So, but for like traditional posts, like shop sabers, ramping out. So if you wanted it to ramp out instead of just pulling straight out of the material, you can turn that on. Helical ramping. So helical ramping is going to do the same motion, but this is looking at the top view of the material. So here's your part, and then this would be like your offcut. And what it's doing is it's doing this same like angle, but it's doing it off of the part. Where this is a good application is if you're doing a lot of laminate or melamine material and you're using a compression tool. As the tool starts to dull, it can chip when it does that initial lead in. So helical is going to help mitigate that chip off of the part itself. The only downside to helical ramping is you're going to want to make sure to bump up your part spacing an additional 16th of an inch over the diameter. So we go a 16th of an inch over the diameter for standard ramping. We go an eighth of an inch over for the helical ramping options. And then helical ramp out is the same idea as the ramp out here. You're ramping out of the material, so you can set that, if you wanted to do that as well.
Okay. And
Yep.
then I got the ramp distance set for 2 inches. So that would be your ramp in. Does that also apply to your helical or your ramp out?
Yes, it does. Yeah, no, it does. It does the same amount. And then zigzag. So this is just the way that it's ramping into the material. So you can see here it's coming in, it's ramping it so to be like a 1-inch ramp this way, 1-inch ramp back, and then carry on. It's just a different style of ramping. I've always just kind of stuck with linear, but yeah, there's an option there for the zigzag as well.
Cut direction conventional is going to go counterclockwise. And then,
Climb would be clockwise. Most panel stock, I've always just kind of stuck with conventional. There is some benefits to doing climb cut for second pass on certain materials. That's like a 25-minute long conversation. There's a great, if you go on the forum and look up cut direction,
yep.
there's a video that CADmate did on the pros and cons to conventional versus climb. Because there's certain materials like plywoods necessarily probably wouldn't want to use a climb cut
Yep.
because of deflection and yeah, all that stuff. But yeah, you got the options there to change. This will only come into play though if you're doing skins. So if you're wanting to do
Okay.
like say a conventional and then a climb cut second on all of your parts, you'd have to do a full sheet skin. If you do just a return skin or onion skin, this will only apply to the return skin or onion skin parts. Your larger parts would just do a conventional pass. Arc corners, this, now I don't know the technical term on this, but what I know is it shortens the line of code that your machine reads going around the corner of the part. So it's not going to round your corners. It's just going to smooth out the operation coming around that corner. So some machines, they're going to come into the corner and almost stop for like a sec, not even a second, and then they're going to change direction. This is just going to smooth out that operation coming around. This is something though you'd want to test with your machine. Not all machines are happy with this setting. Like BSE SEM Homeg, they don't process these properly and actually round the parts. So I'll typically leave that turned off for those machines. And then per part versus stay down. So per part means your machine's going to lead in and lead out for every single part on your table. Stay down is going to lead in once, and it's going to come around your parts. It's not going to cut all the way around. It's going to come to a certain point and then carry on to the next part, come around to a certain point, carry on. It's going to do a full lap around your sheet, and then it's going to, in one pass. So you're going to save a good amount of time with this because you're not leading in and leading out for every single part. It's also nice for guys cutting melamine and laminate, not getting those chipping on the initial lead in, lead outs as well.
Does full sheet skin need to be applied for that to trigger?
It doesn't have to be, but I recommend doing full sheet skin. There's kind of two benefits to this. So one, you're going to have better chance of keeping all your parts on the table, like small parts. But also what I find is when you're cutting any parts with a compression tool, it packs the dust into the channel. So when it does that second pass, it just kind of helps evacuate a lot of that dust. So you end up with less mess on the floor at the end of the day. So, you might be doing an extra minute doing a full sheet skin, but you're maybe saving 2 minutes doing stay down, right? And then you're also saving the time at the end of the day, not having to maybe clean up as much dust around that machine, which is a nice benefit to that. Yeah, so when you're doing full sheet skin or return skin or onion skin, you can set the skin thickness here. So this is the amount of material that's left behind when it does that first pass. So it's going down to roughly about a 30-second above your spoil board. Skin offset, so it's actually going to oversize the parts on that first pass. Now, a 16th of an inch is pretty large. I probably would go more like 0.015. And the reason you might want to do this is if you're seeing any deflection in your tooling or in the sides of your parts, the deflection is going to happen on that first pass. When it does the second pass, it's going to square up the parts to the true size, so it's going to mill off that 0.015. If you're doing tabs or full sheet tabs, this is going to change to the length, right? So that's going to be the thickness of the tab and then the length of the tab, right? So if you're doing like a 2-inch tab, yeah, that'll change for you there. Cutout manually, if you turn on cutout manually, now you'd want to set your skin offset to 0, but this is going to leave the skin on the part. So it's going to cut through, do that first pass, leave the skin there so you could come through with like a razor knife and cut them out. I've used this in the past when I know I have like a sheet of really small parts that are going to move. That way then everything stays together and then you can cut them out on your own. The feed rate reduction, this is going to be a percentage of like 100% feed rate. So feed rate reduction, we're reducing the feed rate by 20% when it does the second pass on your skins. So first pass will run at 100%. When it comes through to do that final skinning pass, it's going to reduce the feed rate by 20%. So running 80% feed rate.
Let's say we have small part handling none, which means that there's not going to be any skins or tabs or anything. It's just going to process, right?
Yeah.
Okay, so let's say you hit tabs just for me. Our skin or tab thickness is 1/32 inch thick and 2 inches in length. And Mosaic is going to place those tabs based on the underlying algorithms. Is that correct?
Yeah, there's no real way to control those.
Okay.
That's going to be done. Yeah, it's the back end of software. Yeah.
Okay, but with those tabs, even though they're tabs, they will come back. That tab length, 2 inches, that is basically just 0.03. Everything else is cut through. Is that correct?
Everything else is cut through. But so tabs or full sheet tabs, this is going to cut out. So it'll do the tabs and then it's going to come back and knock those tabs out. This is where you would turn this on as well. So you could turn this on, it'll cut the tabs and then leave them in place. So you could come back through with like a flush cut saw, right? So this would be for guys who are maybe running like a low vacuum or no vacuum table, right? They're able to cut their parts and keep them from moving because those tabs would stay in place.
Okay, so
Yeah.
that tab side is based. If it's just tabs, that's going to be based on your small part size,
Yeah.
area, or minimum width and length dimension.
Yeah. So surface area, so roughly 12 by 12 or anything that has a minimum dimension of 5 inches.
And then full sheets tabs, that'll apply to everything.
That would override this. Yeah. This.
So onion skin, return skin, full skin. What is the difference? The onion skin. So let's say if we have onion skin checked right there.
Yeah. So onion skin is going to skin your small parts, like what you have is determined as a small part. And then
Okay.
immediately cut that part out. So it's going to do the skin, and then it's going to cut all the way through. Return skin is going to skin all of your small parts, anything that you've determined to be a small part, and then it's going to return back. Once it's done all the skinning of all the small parts, it's going to go back and start over again. And that's where you can actually change up the small part cutout sequence. So you can work with the smallest parts and just make sure to sort your large parts by area. So this is going to ensure that you're actually cutting out your parts smallest to largest that way.
Okay.
When I'm doing stay down, like the stay down nesting with full sheet skin, I typically will stick with shortest movement. That's just going to make sure that your spindle gets around the table in the quickest time.
Okay.
Yeah.
Okay.
It's not backtracking itself anywhere. And then waist pocketing. This is actually a feature I haven't really used this too much, but I've seen this for guys who are doing integrated toe kick, and it's only going to take effect to any toe notches that are facing the inside of the sheet. And what that's going to do when you turn that on, you can set a surface area for that, and your machine will pocket that out instead of cutting it free. So if you ever had like those small parts or small waste parts coming loose and maybe damaging things, you can turn this on to help prevent that from happening.
Okay. So sling it across the room or the
Yeah,
shop
yeah.
floor. I gotcha. Okay. What about the dados then?
Yeah, so dados, you have a few. So this would only apply to dado tools. Run
Yep.
past. So this is going to run past the part type by half the diameter of the tool, just ensuring your parts fit together okay. This
Okay.
is going to be the fastest, like the most efficient way to cut a dado. Most of our customers are using this option, but you have the T-bone and dog bone options as well, which are there. They work good. Yeah, they're harder to hide. You can't hide them with blind dados, but they're here for a reason. Someone's obviously asked for them at some point, so those are options. Pocketing. So these are pocketing options for when you select a tool and the tool set as a pocket tool, you have three options here to choose from. Most customers I've talked to are enjoying the raster. It's going to be cleaning up the pocket in the fastest motion. It's also leaving a pretty clean surface versus these other options. And then you have a radius option here. So if you turn this on, you can add a radius. And what this does is it just radiuses these points. So if you're getting any kind of witness marks when the machine's changing direction, it can help sort of mitigate those witness marks in the panel. There is a forum. If you look up pocket strategy on the forum, there's a
Yeah.
post about this. Couple of
Okay.
people have chimed in on it.
In radius corners, that doesn't. I mean, there's just a couple machines that you won't be able to do that with.
Yeah,
Is
it'd be
that correct?
the same machines like BSEs and stuff. I'd probably keep that
Okay.
turned off. Yeah,
Okay.
I don't personally have any experience. Although SCM seems to be fine with this. I've done some doors with an SCM machine and it's been fine with the radius corners. Something I always recommend to customers just to try it, right? Do a test door, turn it on, see how it looks. Turn it off, see how it looks, right? See what's working best because like any minute that you can save like from having to hand sand these things is just, it's gonna save you money, right?
Oh,
Yeah.
100%. Yeah.
Yeah. Yeah.
Your machine has to be pretty good and trammed in
Yeah.
order to do like an MDF door. That's what that would apply to, is like an MDF door,
Yeah, but
shaker or something.
so, so to give you an example, my buddy who's got the SCM, his machine, he bought it used and it had been crashed numerous times. We know that there's issues with the tramming on it. I've done some MDF doors for a personal project with this, and they actually came out pretty nice compared to
Oh.
the other options. So even with the machine being out slightly, it still did a nice job with that raster.
Okay, well, let's just touch base on the tool properties. I'm not necessarily worried about the ATT tool, the tool sets or anything
Yeah,
like that, but
yeah,
let's
sure.
uh let's go through this real quick, and that way we've got an overview of it.
Sure. So diameter is important. Mosaic works off centerline machining. So what it's doing is it's looking at your part size. It's offsetting a tool path half the diameter of the tool. So if you plan on sharpening, that diameter has to be adjusted before you generate G code. The pass depth and plunge depth, this is the depths that these tools can make in a single pass. Never want this to be more than the cut length of the tool itself. On smaller tools, general rule of thumb is you want that to be half the diameter of the tool. So if you're doing like a 16th inch down shear or compression, right, or an 1/8 inch, you'd want to make sure to change this. If you
Okay.
set this to 0, they're unlimited pass depth. So if you told it to go through a material 2 inches, it's going to go through it in one single pass. So
Okay.
generally, I do not like to leave those set at 0. I'll set them to like 7/8 because I know like they're going to be able to at least do 3/4 material with that. Step over is going to apply to dado and pocketing tools. And this is the amount of material that the tool's already machined. A lot of times I'm going to bring up a help doc. You may
Yeah,
have to,
let me grab.
yeah, just because there's a good visual in here
Yep.
for
Oh,
this.
hang on.
Yeah.
There you go.
So if we just scroll down to the step over. So here's a pocketing tool creating a pocket. So you can see that the step over is measuring the amount of material already machined. So with this in mind, the smaller the value of the step over, the larger amount of material you're going to take out on that next pass. That's kind of some people think, oh, I put a larger number in there, right? Because I want to do a larger pass, and then their machining time takes a bit longer because it's actually the other way around. The smaller the number, the larger amount of material. The
Okay.
rule of thumb with step over is you never want that to be more than half the diameter of the tool itself. We talked about pocket ramp already. The add for through cut. So this is the distance that we're going to be pushing through your material into the spool board when you're using a tool as a cutout tool. That distance could vary because every machine is set up differently. The 0, is set up differently. So that really is going to be just sort of a trial and error. This is a good starting point. If you find it's cutting too deep or not deep enough, you can add to this value. And then the add for blind bore, if you're using a drill that's in the spindle, this is going to account for the spur length of the drill bit. So if you're drilling holes for hinges, guides, shelf pins, right, and you want to fine tune the depth of that hole, that add for blind bore would just make up for that spur length right there when you're measuring those tools.
Okay, I've got a question about the plunge depth. I know what the pass depth is. For that plunge depth right now is set for 1 inch. So that's the depth max that bit will plunge into that
at a time. So yeah, I usually rule of thumb again, I kind of just keep those the same value. So pass depth and plunge depth. Yeah, it should be the same. Yeah, speeds and feeds. So we added some safe values in here kind of to get you started. These really depend. Like 18,000 RPM for a cutout tool, pretty standard RPM. It's going to be the feed rates that you're playing with. You'd want to talk to your tooling rep. They're going to give you a chip load. There's calculators online you can look up to calculate those feeds. You're wanting to make a fine chip, not dust, when you're cutting with your machine. Now, in saying that, not all machines are capable of running optimal feed rates, so don't get discouraged if it's if you're not able to. Just try to get as close to as possible without you're going to get to know your machine, right? If it's screaming at you, you need to maybe speed up the feed rate. Plunge rate typically should be at least half the feed rate value, if not slower. So this is going to be how quickly it's plunging into the material. To give you an example, if you say you're doing like MDF doors and you're using a sharp corner on the doors, I've had some people say like, hey, when I do the ramp out, it looks like the tool's actually over traveling the lead out when it's doing the clean out on the corners. And that sometimes can be from like some play in the Z axis. So I recommend they slow the plunge rate way down, and that actually will just help not have that spindle over travel the corner of the operation. Yeah, it's just a one fix. The priority number, you can ignore this. This doesn't apply to anything in Mosaic anymore. It used to at one point. The T mapping number, this would be just for specific machines that need an actual mapped tool number. And then your application. So you can set up roughing tools. So roughing tools will only come into play for your first pass if you're using skins. Right? If it's not turned on, then it's not going to grab this. And then cutout tool is going to do your final pass, or we'll do your cutout for all parts. Drills, obviously, for drills. Dados are going to be for any kind of dado tools. So dado tools are called automatically in Mosaic. Mosaic tries to fit the largest tool in the groove. Example, you have a 1/4 inch down shear, a 3/8 down shear, and a 1/2 inch down shear in your tool set. You're cutting a 3/4 inch dado. It's going to grab the 1/2 inch down shear every time, because it's going to be the largest tool can fit in that groove. Pocket tools. So pocket tools have their own pocket strategy, so that's why that's there. But you also have the option when you're setting up your door pocket tool, you can actually select use pocket tool. So you don't have to specify the exact tool. You can just say use pocket tool, and Mosaic's going to grab the tool that it sees as a pocket tool in your tool set. Dovetail takes, we have a few set up in here already, which are right here. And when these are selected as Dovetail, really all it does is just make sure to take these tools out of any automatic operation. So they're not going to get called into like cutting a dado or doing any outline cuts. They're only going to come into play for when you have a Dovetail drawer set up. Sharp corners, those are hard-coded in the software to run at the angle of the tool. So when you're doing like MDF doors that need a corner clean out, they're going to run at the angle. And these are included angles. So a 90 is a 45, a 60 is a 30, and so on. It's going to be half the angle of the tool. CNC door is going to be any tool that has a shape. So if I grab any of these vortex tools that are a CNC door, click on tool shape, you can see the geometry of the tool. We did a webinar on this, on how to create shapes. You're just showing half the tool geometry. So I definitely would reference that if you wanted to learn kind of how to draw.
So basically
tools.
the CNC door, once that is selected, let's say if you're doing a raised panel door or an MDF door and you have some kind of a profile for that outside edge, that's all that's going to do is show that in a 3D visual for you, for the customer. Is that correct?
The more accurately that those are drawn in the tool shape, it makes this panel tool group setup like so much simpler, because you're able to pull these in. You can actually see like the profile. You can see where the tools are coming in, right? You can make like little adjustments just to make sure that you're getting a nice clean finish on the tools. So yeah, these were all drawn in that panel or in the CNC door tool, and that's really all that setting does. It doesn't choose that tool automatically. You'd have to add them to the panel tool group.
So you could turn that CNC door off for those 4 bits and you wouldn't see it visually, but it's still going to select those bits and cut that profile.
Correct. Yeah.
Okay, perfect. Mr. Wallace, like always, you are a definite wealth of knowledge. And I certainly
I try.
Yeah, I appreciate it. I really do, sharing those thoughts. You have anything else to add?
Oh, one thing I will point out, when you get into, and this is something that if you have multiple machines, or maybe you've copied a machine when you're setting up your tools, just take note that that it's going to be the toolpath properties are by machine. So one thing I've commonly seen is like the CNC router is the default tool, but if you've created a CNC and called it, say, like SCM tool or SCM CNC, when you come into here, you might not notice that it's still on the CNC router. Set all of your tool properties, and then go to run it, and no changes have happened because it actually has changed it for the CNC router, not for the machine that you've maybe added to your list. So just keep an eye out for that. I know that's a common one I've seen. I've even done it too. I'll do a setup sometimes, and I go in here and I make all the changes, and I go, oh, I'm on the wrong machine. We got to change that and change everything back to the correct machine. So.
Yeah, I know I had that set to table saw, but obviously these all apply to the CNC. So,
yeah,
100%.
All right. Yeah.
Well, sir, I certainly appreciate it.
Yeah, no worries, man.